We're covering inverses from cofactors and determinants. So we already have a method to find the inverse of a square matrix, which is method 1. And that involved placing the matrix entries in an augmented matrix together with an identity matrix. So if you recall, you had a square matrix A, and to find its inverse, if it had an inverse, what you would do is place its entries on the left-hand side of an augmented matrix. You'd have a long vertical line, and that would separate this matrix from an identity matrix of the same dimensions as A, and then that would be your augmented matrix. What you'd then do in method 1 is try and transform that into an identity matrix using row operations. And once you've done that, once this is an identity matrix on the left-hand side of this vertical line, what you would have here is the inverse matrix on the right-hand side of the vertical line. So that was method 1. It was really easy to understand method, and even though it was a bit easy to understand, it did take a little bit of time, but again, it was an easy method to apply. Now we're going to learn about another method. And the second method uses cofactors and determinants to find the inverse of a square matrix. Now, before we study this method, and I call it method 2, we need to cover a prerequisite called the adjoint of a square matrix. Because in method 2, we are going to be using something called the adjoint of a square matrix, and we need to understand what that is first. So let's discuss the adjoint of a square matrix, and it's nothing complicated. All right. So consider an n by n square matrix A. All right. So that A matrix, it's going to have its entries A11, A12, and then you'll have A21. Okay. All your entries ANN, last entry there. Right. Then what we are going to do is we are going to, so once you have the square matrix, what you're going to do is calculate all of the cofactors, and you already know how to calculate cofactors. So you'll calculate the cofactor for the first row, first column, that will be cofactor 1, 1. You'll calculate it for the first row, second column, cofactor 1, 2, and so on. You'll calculate all the cofactors, cofactor 1, 3, and you'll go cofactor 2, 1, etc. Right? You calculate all the cofactors. The last one will be cofactor nn for an n by n matrix. Then what you're going to do once you have calculated all these cofactors is you are going to place them in their very own matrix. So cofactor 1, 1 will be in row 1, column 1. Cofactor 1, 2 will be in row 1, column 2, right? And so on. They will take their respective positions. And that's what you're going to get. Okay, so that is called the matrix of cofactors of A. So cofactor 1, 1 all the way up to cofactor 1n. That's the cofactor for the first row, last column, and you can kind of see the pattern. So you're going to get the matrix of cofactors of A. Now, the adjoint of this A matrix that you were given, it's denoted by A, D, J, and then in brackets A. It stands for adjoint of A. The adjoint of A is simply the transpose of this cofactor matrix that you calculated. So just to recap, to get the adjoint of this square matrix A, you're going to get or calculate rather, the matrix of cofactors. Then to get the adjoint, you simply transpose this. So you transpose this matrix, and there you go. That's your adjoint matrix of the matrix A. That's how simple it is. All right, let's do an example. Let's work out what an adjoint is in practice. So exercise 1, I want you to find the adjoint of this matrix. If you want to go through it on your own, pause the video now. All right, let's do this example. So the first step to calculating the adjoint is we need the matrix of cofactors. So let's work out the cofactors. Cofactor 1, 1, so that's going to correspond to entry 1, 1. What we're going to do is let's account for the sign, or basically use the checkerboard matrix, and it's going to be a positive 1. So it's going to be positive, and then we'll have to work out the determinant of the resulting submatrix when we delete entry 1, 1 from this matrix A. So it's going to be minus 2 times minus 1 Okay, and that's going to be 2, so minus 2, minus 1, and this is the submatrix. Once you work this out, it's minus 2 times minus 1, that's 2, minus 2 times 0, that's going to be positive 2. Right, and then I'll just fill in the remaining cofactors, or the working out for the remaining cofactors. So cofactor 1, 2, that is going to be 2, 0, 1, minus 1. Okay, and because it's in first row, second column, we need to account for its sign, so it's going to be a minus in front of that. Once you work this out, it is going to be positive 2. Cofactor 1, 3. So count for its sign, it's going to be a positive. The resulting submatrix is going to be 2, minus 2, 1, and 2. Working out this determinant, let's check. It will give you 2 times 2, 4, minus 1 times minus 2, that is going to be positive 6. Right, cofactor 2, 1. You have to account for its position in the checkerboard matrix, so that's going to be a negative. Right, and then we'll fill out the determinant of the submatrix 1, minus 1, 2, minus 1, and that is going to be minus 1. All right, let's add a page. Okay, then we have cofactor 2, 2. So accounting for its position, it's going to be a positive 1. Determinant of the resulting submatrix is as follows. Okay, and then work that out. That is going to be minus 2. Okay, this is going to be a minus, and then we're going to have 3, 1, let's check 1, 2, and this determinant is going to be, let's see, minus 5. Okay, then we're doing the cofactors for the last row of our original matrix. This accounting for the checkerboard matrix, that's going to be a positive. Okay, and then the determinant of the submatrix is as follows. Okay, so cofactor 3, 1 is minus 2. Cofactor 3, 2, so that is going to be a negative. And then we'll have 3 minus 1, 2, 0. And that's going to be minus 2 as well. Okay, last cofactor, cofactor 3, 3. Okay, positive, accounting for the checkerboard matrix. And then 3, 1, 2, minus 2. That is going to be minus 8. So there are all your cofactors. You will have to do this for each entry. You'll have to get all the cofactors. Now what we're going to do is we're going to get our cofactor matrix. So I'll just write CM. Okay, so CM for short, you know it means cofactor matrix. Our cofactor matrix is going to be this. So it will be 2, 2, 6, minus 1, minus 2, minus 5, minus 2, minus 2, and minus 8. There we go. And if you're asking where did you get these numbers from? So they are just the cofactors. So the first one was 2, 2, 6, right? So let's take a look. 2, 2, 6, and then cofactor 2, 1 was minus 1. Cofactor 2, 2 is minus 2, then you had minus 5, and the last cofactor was negative 8. So this is your cofactor matrix or matrix of cofactors. Then the transpose of this is going to be your adjoint. So the adjoint, okay, and we had matrix A is equal to, and it's going to be the transpose of this cofactor matrix here. So the first row becomes the first column, that will be 2, 2, 6. The second row becomes the second column, that's minus 1, minus 2, and minus 5. And the third row becomes the third column, that's minus 2, and negative 8. So there's the adjoint matrix for A. All right, that's example 1 covered. Okay, exercise 2. So again, find the adjoint of the matrix A, and there you have the matrix. All right. So to find the adjoint, the first thing that we need are the cofactors, and then we're going to put it in the matrix of cofactors. Then we're going to transpose that matrix to get the adjoint. So let's go for the cofactors. Cofactor 1, 1, it's going to be a positive. Oh, let's not even indicate that. Okay, it's going to be the determinant of the submatrix 3503, and that's going to be 9. Cofactor 1, 2, so we need to account for the negative, and then it will be 2, 5, 1, 3, that's going to be minus 1. Cofactor 1, 3, accounting for checkerboard, it's going to be positive, resulting determinant of the submatrix, and that is going to be negative 3. Cofactor 2, 1, it's going to be a negative, accounting for the checkerboard. Then the submatrix is going to be minus 1, 2, 0, 3. That is going to be positive 3. Cofactor 2, 2. So checkerboard is going to be positive. Then we're going to have 1, 2, 1, 3 for the submatrix. That's going to be positive 1. Cofactor 2, 3, accounting for the checkerboard, that is going to be negative. And then the submatrix is going to be 1, minus 1, 1, and 0. That should give us minus 1. Cofactor 3, 1, checkerboard is positive, and then we are going to have minus 1, 2, 3, and 5. That is going to be minus 11. Cofactor 3, 2, checkerboard is going to be negative, and then we are going to have 1, 2, 2, 5, and that is going to be minus 1. Cofactor 3, 3, so it is going to be positive in terms of the checkerboard matrix, and then we're going to have 1, minus 1, 2, 3 for the determinant of the resulting submatrix, and that's going to be 5. So there are all our cofactors. Now it's time to get the cofactor matrix. I'm going to write CM for short. You'll have to write out the full thing. Cofactor matrix is equal to, and the cofactor matrix is going to be 9, minus 1, minus 3, 3, 1, minus 1. And we will have minus 11, minus 1, and positive 5. Then to get the adjoint, you're going to take the transpose of that cofactor matrix. So what you will have is the adjoint of A being as follows. So it's going to be 9, minus 1, minus 3 in the first column. It's going to be 3, 1, minus 1 in the second column. And it is going to be minus 11, minus 1, and positive 5 in the last column. And there is the adjoint of matrix A. So that's example 2.